How does the Rankine cycle use waste heat? Imagine finding a way to turn something that's usually thrown away into useful energy. That's exactly what the Rankine cycle does when it uses waste heat. This cycle is a process that transforms heat into mechanical work, often to generate electricity. Instead of relying solely on fresh fuel or high-temperature heat, it can also make use of heat that would otherwise go unused. Waste heat comes from many sources like industrial processes, engines, or power plants. When these sources produce heat that isn't needed for their main work, it's often released into the environment. The Rankine cycle can capture this heat and turn it into electricity or mechanical energy. Here's how it works step by step. First, waste heat from an industrial process or engine exhaust is transferred to a working fluid inside a boiler or evaporator. This heat raises the fluid's temperature and pressure, turning it into vapor. In some systems, like organic Rankine cycles, the working fluid is an organic compound with a low boiling point. This allows the cycle to use lower temperature heat sources efficiently. Next, the high-pressure vapor expands through a turbine or expander. As it expands, it produces mechanical work, which can be turned into electricity with a generator. After this, the vapor cools down in a condenser, turning back into a liquid. The liquid is then pumped back into the boiler to repeat the cycle. Using waste heat in this way boosts overall energy efficiency. It captures energy that would normally be lost and puts it to good use. This process helps reduce fuel consumption and cuts down on greenhouse gas emissions. Many industries benefit from this, including steel, cement, and glass manufacturing. Internal combustion engines also produce waste heat that can be recovered. The organic Rankine cycle is especially helpful here because it handles lower temperature heat sources better than traditional steam cycles. In summary, the Rankine cycle uses waste heat by capturing residual thermal energy from industrial or engine exhaust. It then converts that heat into vapor that drives a turbine, producing electricity or mechanical work. This process makes energy use smarter and helps reduce waste, turning what was once lost into something valuable.